Hello everyone. We are going to tackle a problem involving parametric equations for projectile motion. Projectile motion is, projectile motion is traditionally problems that involve, say throwing a ball up in the air, hitting a baseball, kicking a soccer ball, a dolphin diving out of the water. Typically, what they look like is, typically what they look like is some sort of an upside down parabola. So it'll, okay, what is going on here? So it'll look something like this. So it's called projectile motion. So what we're going to do, whenever you have a projectile motion problem, the equations that they're going to give you look like this. They involve trigonometric words. So what we're going to do is we're going to go ahead and set these equations up. I'm going to write them over here. We're just going to fill in the numbers. And then we're going to go to Desmos and graph this. If you have a TI Inspire, they graph it much easier, but not everyone has a TI Inspire, and so I'm going to go to the Desmos app and do that off of Desmos. You can always follow along on Desmos. Everybody can access Desmos. If you are using a TI Inspire, you could always shoot me or your pre-calc teacher an email and ask how to do that. But everybody's going to learn how to do Desmos on here. So what we're going to do is we're going to fill in the problems here, and then we can get ready to type them in and go to www.desmos.com. So, okay, we've got an arrow being shot upward, initial velocity of 81 meters per second, and an angle of 21 degrees with respect to the horizontal. The arrow is shot from a height of 5 meters above the ground. Okay, so what they're saying is the arrow is being shot 5 meters off the ground. It's going to go through the air, and sooner or later it's going to start coming down and falling. So it's going to look like that. That's what we're going to be looking for on our calculator, on Desmos. So we're going to fill it in. Here we go. We need two equations in parametric mode like we've been talking about. So this first one's going to be x equals, now VO is the velocity, 81. And then we're going to have the word cosine there. And then we're going to put our angle, which is 21 degrees. And then we're going to put the t at the back. T stands for time. T is saved for time, and it's usually in seconds. Okay, our second equation, y equals, we've got negative 4.9 t squared. And then we're going to add our velocity, which is still that 81. And we're going to put sine. And then we're going to put our angle, which is still 21 degrees. And then we're going to put the t, and then we're going to add that initial height, which is 5 feet off the ground. So these are our two equations that we're going to type into Desmos. Okay, so what I do now is I'm going to go to Desmos, and we're going to see what's going on. Okay, so I got Desmos up here, and again, I just did www.desmos.com. Now what we're going to do is this. You're going to go over to this wrench, and Desmos defaults to radians. So what we're going to have to do is we're going to have to switch this to degrees. And then when we type in a parametric equation in Desmos, we type it in as an ordered pair. Now on an Inspire, I would have to change my mode to parametric. And again, if you have an Inspire and would rather do it on Inspire, you could probably Google that too. I bet you it would go through and tell you how to do that, some YouTube video out there. But again, I have to show Desmos because everybody can do Desmos. It's going to be an ordered pair, so I'm going to start off with parentheses down here. And I'm going to type in my two equations. The x equation was 81. And then cosine, if you hit this functions menu right here, it'll bring up your trig functions, so cosine. And then 21. The t goes after the parentheses, so you have to get the t back here. Okay, you're going to notice it brings up an add slider. You don't want to do that. Just hit a comma. And now we're going to type in our y equation, which was negative 4.9 t squared. The squared is right here, so I'm going to hit the squared. And then I'm going to do plus 81 sine t. So again, I'm going to hit the functions button here. And I'm going to put the 21 in here, the t on the outside, and then we're going to do the plus 5. Okay, now for t, What we're going to do is we're going to set our parameters here to be between, okay, we got to go to our window here real quick. And I see this little piece of the graph, but for the window, we're going to change our x-axis here to be between -5, and we're going to go up to probably about 50. We'll see what happens there. Okay. And that, so we're thinking the arrow's gonna be airborne and hit the ground in 50 whatever feet. The y-axis, we're gonna go from -5, and we're gonna go, this would be the height, so we're wondering how high that arrow's gonna be. I don't know, 40, 50, we'll try something. 40. Okay. Okay, so there's that. So I see part of my graph here, but now what do I need to do is I need to go back, and I need to change my t, my parameter up here. Now t is time, and so it's in the air starting at 0 seconds, and it's going to be in the air way longer than 1 second. So they're just giving me, yeah, uh, to 1 second. So maybe I'll do, I don't know, -10 to +10, and then that way I'll be able to see the whole parabola, and we'll see if that works. And let me get rid of this right here. Okay. Okay. So now if I just move my graph a little bit here, that's the cool thing about Desmos is I can move my graph, and it looks like I want it to be way more than 50. So maybe I'll zoom out a little bit. Oh yeah, there we go. Okay. So that's the cool thing about Desmos is I can zoom out and zoom out and zoom out. Okay, so there's my graph. And if you got lost in any of that, it's cool. You're on a recording. You can just stop and go back. Okay, now to answer the questions on my notes, I haven't really even done that yet. Question A is how long is the arrow in the air before it touches the ground? So visually speaking, we're wondering this. Wait, where's my decimals? Oh, here. Okay. So visually, we're wondering like this point right here. Now on an Inspire, I could just hover and it would show up, but on Desmos it does not, and there's no trace option. So what you're going to do is you're going to go over here, you're going to create another equation. We're going to type in the same exact equation, except don't use the letter T. You can use any other letter, but just don't use T. So I'm going to use A. So I'm going to come over here, and I'm going to do the same exact equation. And, but I'm not using T. I'm going to, like I said, I'm going to use A. Now it brings up add slider. You want to now add a slider. So we're going to add a slider. Okay, now I'm going to keep going, so I'm going to put my comma. -4.9 t, no, not t, a squared. 81. Oh, yeah, sine. Okay, so function, so that would be sine. And then 21. And then we're going to call that a. And then we're going to do +5. Okay, now, yes, we're going to label. Okay, and I can't remember what I typed in here. I don't think I typed anything in there. Okay, so now, this is cool. So what you can do is you can grab this slider and you can move it to any point you want, which is way cool. This is how my Inspire traces. So now you can just drag it and you can answer the questions, okay? Now you can also go over here. There's this cool menu over here. You can get it animated. You can do the speed. You can actually have it just go. It can just be you can just go slow and then hit it record, so it'll trace the graph for you. But I kind of like to manually have control over that, so I'm going to stop. And okay, so now, very cool, very cool. I had to YouTube it because I did not know how to do this on Desmos because I don't use Desmos. I use my Inspire. So let's answer the question. Okay, first question. How long is the arrow in the air before it touches the ground? Okay, so Well, okay, it's going to touch the ground over here. So I'm looking for it to zero out. So the Y value back here should be 0 because that's when it's going to be touching the ground, or as close as I can to get 0. Somewhere in there. Okay, so it's about 460, about 460 feet. Okay, roughly. Okay, so 460, um, oh, no, how long is that? That's the distance. That's the horizontal distance before it touches the ground. Okay, so that's the horizontal distance. So 460 feet. Now, if you have 461, I think, let's see, is that, let's see, 400, actually, it should probably be 461. Well, it would round up anyway, so 461. Perfect. Okay. Now, so then the other question was the time. How long was the arrow in the air? This is your A. A, remember A replaced T, and T is for time. So this number over here, 6.09, that is your time. So that'll actually answer our first question, 6.09. How long is the arrow in the air? And that would be seconds. Okay, what else we got going on this page? Not a thing. Okay, so very cool stuff, but a little involved, but quite a process, but it's very cool. We were going to make this 461, weren't we? Yes, we were, because rounding that would round up. So 461, let's make that 461. Bam. Okay, there we go. Okay. Woo!